Hello everybody, welcome back to Bare Basic Tech. Today I'm going to continue on with part 2 of classes. So what we covered last time in classes was a very basic syntax and use for classes and an introduction to the concept of object-oriented programming. So to review, here is the syntax that I went over with you guys, where you define your class and then simply name the variables inside of it. And then you would construct an object like so. However, there are some downsides to this, and that's why I want to go ahead and go over that with you guys in this part 2. This is something you'll see more as a standardized used kind of thing, and I highly recommend you adapt it to whatever program you're writing. So let's go ahead and get started. So essentially, this is going to be the new syntax I'm showing you today. So there's two reasons why, and I'm going to show you what I mean, but there's two reasons why I recommend using this method instead. But essentially, to break it down here, I'm just going to explain. So just like last time, you would have your class keyword followed by the name of your class. And then under it, just for now, take my word for it, you're going to write this def init self thing here, right? So what this does is it's a pre-programmed function in Python that is used to instantiate classes when they become objects, right? So as you can see here, there's a couple other things underneath the init function here. So we have self.variable1 equals a number, and then self.variable2 equals some string, right? So this is just a different way of instantiating variables, similarly to the old method that we learned here. It effectively does the same thing as this. So it's going to initialize variable 1 under the square class and variable 2 under the square class. Same exact way here. Now I'll get into some of the differences in a moment, but for now, just take my word for it that this is what we're going to be going over today. And I'm going to show you why it's better, but just realize that this ultimately accomplishes the same thing that we were going over in the last episode, but it just gives you a little more control, and I'll show you what I mean. So how do we implement this? So if we wrote this into code similar to our last problem set, you would see here we have the basic square class, where we want there to be a variable for color and we want there to be a variable for weight. So again, we'd write the class keyword and then new square will be our class name, followed by the init function, where we would have self.color is black and self.weight is 1. Now, if we're going to go ahead and instantiate a new object, again, similar to last time, we have this red square here. We're going to go ahead and do basically the same thing that we did in the last video. So square 1 would be new square, and then you can go ahead and manipulate the attributes of that square here, right? Because remember, this square 1, now that we set it equal to the new square class, now inherits all the properties of new square. So it's going to inherit all of these variables that you see here under the square class, right? So one of the questions I'm sure you're probably having is, what is this self word? So think of it as a pointer to itself. Now that may still sound confusing. So what that means is, think of, instead of self being written here, you have the object here. So it's like, instead of saying self, just think of it as, in this case, square 1. That object, square 1, is the same as self. Okay? So square 1 dot color is red would match up with this right here. Again, just think of self as the name of the object that it currently represents. And again, I'll go over that a couple more times as we go through the video. It'll make more sense once you see it. But again, just think of it as a sub-attribute of the object that it is instantiated with, right? So on to this next example, we have the same example as last time with the thin green square. So we're going to go ahead and again make our new square class as shown. Nothing has changed with it, right? It's still just the same base class that we expect our object to inherit all the values from. So nothing has changed here. This is the same as the last example. Now when we go to initialize our green square, again, we want the color to be green and the weight to be 1. So because it has the default weight already of 1, we don't need to worry about initializing that variable. We just need to worry about the color because that will be different. I'm going to go ahead and just spot that in there. So when we go ahead and initialize that, we have square 2 equals new square. And then we would set the color of square 2 to be green. Again, just like down here, this is giving the self.color value when it's initialized this new value of green, right? So it'll be, again, the same thing as last time, essentially, just a slightly different syntax when we're initializing the class. And then for the thick black square, it's the same concept again. Just now, since we already have the square being black, we don't have to worry about explicitly declaring that variable. And then for the weight, since that'll be different, we will go ahead and declare that as 2 after instantiating the new object, right? So let's go ahead and look at this in code for a second. So we come over here. We have just, again, another rundown of the syntax for the class. And then here's a basic example of what we were going over. But I'm going to add something new into it, and it's going to come down later. That's where you see this, but don't worry about it just yet. So we have the same variables of color and weight. And as you'd expect, it's going to do what we want it to do, right? So first it prints out square 1 color, which is red and 2. Should make sense. Then we come down here to square 2, color and weight, and we get green and 1, which again, square 2 color is green, and then we don't explicitly declare the weight, so it's going to use the default value from the class. Then we come down to the last example here, where it's black and weight of 2. And as you can see here, we print the color and weight, and that is what it'll give us, because we had only declared the weight. So the color would still be the default of black, right? So that's just a simple example to show you that this works essentially the same exact way as what I had shown you in the last video. Now you're probably wondering, so why are you showing me all this? What's the importance of this, and what makes it better for me in the long run when I'm making my code? Why do people use this over the original way that was shown? It looks simpler that way, so why not just use that? So I'm going to explain it with 2 reasons. One, I think something that you wouldn't initially catch, but it'll come to get you in the long run, is that while it will save basic variables from one instance based on a class to another, it will not save arrays specifically. So if you were to have some kind of an object that was based off the square class that had this array, right, and then you were to manipulate it, and then you were to make a new object based on the square class, although these variables here would be unique to that object, for whatever reason, the array will stick with all objects that base from the same class. So what does that mean? So I'm going to run this example here to show you what I'm talking about. But basically, I'll talk through it and tell you what you should expect. So we're going to make a square based on this class. We're going to call it square 10. And then we're going to go ahead and we're going to take the array here, and we're going to just throw on a new item in there. We're just going to give it just a string of x, just to show you. And then we're also going to show you that square 10's color is going to change to green. We're going to go ahead and print out square 10's array and square 10's color. All right, so you're going to see what it's set square 10's basic values to. And then we're going to go down here and do square 11, which all we're going to do in square 11 is change the color to red. Okay, and then we're going to go ahead and print the array for square 11 and color. Now what you're going to notice is really interesting, and it's that the color for square 10 will be different than square 11. However, the arrays will both be the same, which shouldn't be the case, you would think intuitively, because we never added anything to square 11's array variable. So let's go ahead and run it. So as you can see, let's start here. Square 10 array and color. Array, which is printed first, right? So we have the array. So 0, which again, it naturally has from the base class, right? And then it gives us this x that got appended on there. Yeah, so that makes sense. because we know we did that because we appended that to the end of square 10's array, right? So we know we did that because we explicitly went ahead and did that. However, when we get down to square 11, that's where it gets a little odd, right? Because you see here, we ask for it to print out the array, and it does, but hold on a second though, it has this x value here. So it took that from this line of code right here, right? Which is kind of odd. So again, that's why this method won't really work if you're using arrays in your classes, because it will share the value of the array across any and all objects that inherit attributes from this class. Okay, and just to show you also, I'll go ahead and comment this out just to see that when it doesn't run, what happens is that the array for both still stays a 0, right? So it really was just this one line of code here that caused that. So just keep that in mind. But that's why, or at least one of the reasons why, it's important to make sure you're using the new method that I'm showing you. So to counter that, this is an example of it working the way we wanted it to, right? So it's a similar example. I just renamed the squares to be 12 and 13, and then the class is now called new square. But same concept otherwise. So we have square 12 equals new square. So again, this class. We're going to go ahead and append x again, and then we're going to have it show us the array of 12. And then we're going to make a brand new square called square 13, and then we're going to see what square 13's array is. Watch what happens. And look at that. So square 12 prints out 0 and x, while square 13 only prints out 0. So again, just to back up the point, that's why, or one of the reasons why you use this. So that this way, if you want to have arrays in your class, which you will, this can make it a lot easier, obviously, because each of your objects that are derived from a class can go ahead and have their own different items in their array. All right, so moving on to reason number 2, and I'll keep this one a little quicker, is that you can instantiate your objects a little bit more concisely, if you will. So I'm going to go ahead and show you down here a slightly even better syntax, I'm going to call it. So it's the same thing, except you're going to write it just a little different, but same concept. So what we're going to do here is back here where we have the init function, we're going to pass it some arguments, right? So for the sake of an example, I'm just going to put variable 1 and variable 2 in as my 2 arguments, right? And then underneath that, where we have, you know, that self and then the variable name written out, we're going to go ahead and set that equal to the argument that was put into the function. Now, generally, it's a good practice when you're making these and you're designing your classes. The arguments names that are put here should match this name here, just to make it easy to see and understand from a programmer's standpoint. Okay, so you would just set self variable 1 equal to the input argument of variable 1, and then self variable 2 equal to the input argument of variable 2, right? So to show you how this works, just in a simple example again. So let's have our variable 1, variable 2. So we have 1 and we have 2. Okay, so we have variable 1 and variable 2, and then we go ahead and punch them into the name class like so. That would give you first name. Now that's an object of the name class where we input variable 1 and variable 2, and it will put in these values. So then it will go ahead and set variable 1 of first name to being 1, and then variable 2 of first name to 2. Now in the next line, let's say I wanted to manipulate the value for some reason. You would just do, as usual, first name dot variable 1 equals your new value. So let's just throw 3 out there. So variable 1 would now be 3. Okay. So really, the only thing that's different here is now instead of just, you know, how we were doing it last time, where it was like first name equals name, and then we'd have these empty parentheses here. These parentheses, this is pretty much their purpose, right? So this is where you would fill them in with your input arguments for how you want to initialize that class. Okay, so just think of it as a one-line way of being able to write out what you want each variable to be. So I'm just going to give you guys one example to show you that in practice to the application we've been doing. So let's say we have the red square again, right? Now instead of all the other stuff that we were doing in the old examples, I can initialize this in one line of code with the new and improved class syntax, right? So again, this is going to be almost the same, right? The difference here is that we're going to add our input arguments of color and weight to the initialization function. Now where we utilize those input arguments is where we go ahead and initialize our self.variable attributes, right? So in this case, we have self.color, and we're going to set that equal to the color input argument, and then the self.weight attribute equal to the weight argument. Now again, like I mentioned, I made sure that this name was the same as this, and that just adds some consistency so that's easy for the programmer to understand. In theory, you could, just for example's sake, you could do this, right, where you could name it something different, and the same thing would still result. You would still access it as just color, but again, it just makes it more readable and easy to understand for the programmer what's going on here when you just keep it all the same. So now we go over here and we want to initialize square one as our favorite red square. So square one would equal, new square, and we would give the input argument of red and 2. That would give you this. So again, to show you in a practical example in the code, again, we have the same thing here where we would just input our arguments up here. And then when we go ahead, let's say I want to make my square called square 20, we'll set that equal to new square and give it some inputs of the color black, a weight of 3, and this strange array for whatever reason. So now we go ahead and print that out. It's going to go ahead and tell us square 13's variables are black as the color, 3 is the weight, and this crazy weird array as the array. So that's all I have for you guys today. Thank you for watching, and yeah, if you guys like the video, please feel free to like and subscribe. Thank you.